Hello everyone. Today's topic is Euclid's division lemma. Now the term seems to be very heavy. I have seen a lot of students getting scared of this terminology, but no need to get worried. Here, Euclid is name of a famous Greek mathematician from mid 4th century BC. He wrote a book called Elements which had 13 volumes, and 30th postulate of his 7th volume refers this division lemma. Carl Friedrich Gauss also, in his book Disquisitions Arithmetica, written in 1798, refers about Euclid's division lemma. That's why the generalized form of Euclid's division lemma is also known as Gauss lemma. Now, what is the meaning of term lemma here? This lemma is nothing but a proven statement which is used to prove another statement. Division, because Euclid's division lemma has to do something with division, that's why this division word is here. Now, before I explain the meaning of Euclid's division lemma, let's go back to our upper primary classes where we have done how to divide two numbers. Let us consider we have 155 divided by 7. Now let us once again divide these two numbers. We will get quotient as 7 times 2 is 14, 5 and 15. Now again 7 times 2 is 14, the remainder is 1. I'm sure each one of you can divide these two numbers. In junior classes, we also have done this number 155 is known as dividend, 7 here is divisor, 22 is quotient and 1 is remainder. And you were also taught that dividend is always equals to divisor into quotient plus remainder. Now if I write the numbers here, 155 equals to 7 times 22 plus 1, and we were also taught that this 1 cannot be greater than divisor, means 1 has to be greater than equal to 0, a positive number, and it has to be less than 7. So remainder is greater than equal to 0 but less than divisor. Now if we divide these two numbers n number of times, you divide it 10 times, 20 times, 30 times, every time the quotient will be 22 and remainder will be 1, provided your division is correct. Which means for these two given numbers 155 and 7, quotient and remainder, these are unique numbers. So 155 equals to 7 times 22 plus 1, where 22 and 1 are unique numbers. Always we'll get the same two numbers. And if I generalize it, if I write dividend as A, divisor as B, quotient as Q and remainder as 1, I can write the statement as A equals BQ plus R, where remainder has to be positive but less than quotient. Remainder can be equal to 0 also. So the same mathematical equation, if I try to write or to express in the form of words, I will say for any two given positive integers a and b, there exists unique integers q and r such that a equals to bq plus r and value of r is greater than equal to 0 but less than b. I will read it as for given two positive integers a and b, there exists unique integers q and r. Why unique? Because you divided number of times, every time quotient and remainder will be same, satisfying this equation a equals to bq plus r, where value of remainder either equals to 0 or positive but less than b, means less than the divisor. So this is nothing, this statement is nothing but Euclid's division lemma. So very simple, very easy, just correlate it with what you have done in upper primary classes, the long division method. This statement is known as Euclid's division lemma. Now, let us try to express these given integers in the form of A equals to BQ plus R. Try, pause this video a few minutes, and then we shall verify the answers. Hope you must have done it. Now 10 can be expressed as 3 times. Let us read out the multiplication table of 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. And when I multiply 3 by 4, 3 times 4 will be 12, which will be greater than 10. So I have to multiply 3 by 3. 3 times 3 is 9. What shall I add to get 10? I will add 1. Now this is a value of A, this is a value of B. It means our quotient is 3 and our remainder is 1. Now for second number, 17 equals to 6 times 3 is 18, which is greater than 17. So I have to multiply 6 by 2. 6 times 2 is 12. And what shall I add in 12 to get 17? I'll add 5. So what is quotient in this case? Q is 2 and remainder is 5. Let us write it here. Q equals to 2 and R equals to 5. Similarly, in first case, Q equals 3 and R equals 1. Next example, 81 equals to 3 times. 81 is a multiple of 3 and 3 times 27 will give me 81. So which means the remainder will be equal to 0. Here quotient is 27 and remainder equals 0. Last but not the least, here kindly note that 5 is less than 12, which means 12 has to be multiplied by 0 and then the remainder will be 5. So in this case, quotient equals to 0 and remainder equals to 5. So this is how we can write two numbers A and B in the form of A equals BQ plus R, where Q and R are unique integers, positive integers in fact, and value of remainder has to be greater than or equal to 0 but less than the value of divisor, that is B. So this was all about Euclid's division lemma. And if you like this video, hit on like button, subscribe to watch more videos. Thank you and have a nice day.